Alright guys, so here we have day 2 of creating systems of linear equations. So again, today this is all about, hey, can you actually write the equations, the system? I'm not going to give it to you guys all the time. So again, this is day 2. Alright, just recall a few little important tips here. So again, make sure you're organized, make sure you're going through and you're highlighting, underlining all those key parts. You can always draw a picture, and it's always important to label your variables. What does the X stand for? What does the Y stand for? Keywords to look out for, phrases are things like per, monthly. They're expressing some change in rate. You know that those are going to have a variable right after it. So if it's like $40 per month, you know you're going to end up with something like 40x, right? Or if you have a $25 weekly allowance, so weekly, $25 per week, I could use W to represent weeks. And again, solve using best method. I'm not going to force you guys from now on. Again, it's up to you. Alright, so here we have example number 1. It says it costs $35 for an adult and 2 children to attend a show. It costs $60 for 2 adults and 3 children to attend the same show. How much does it cost 1 adult to attend the show? Okay, so here I have 2 different cases they give me, right? So the very first one here, it says it costs $35 for 1 adult and 2 children. Okay, similarly, we have that it costs $60. So it costs $60 for just 2 adults and 3 children to attend that same show. Okay, so now what's the question? What are they asking for? So it says how much does it cost for how much does it cost 1 adult to attend? So I'm worried about the cost just for 1 adult. I don't care about the kids. I could care less about the kids. All right, all I want to know is how much does an adult ticket cost, because I'm an adult, that's why. Alright, so let's figure this out. Now again, I know I have a system because I'm taking a look at 2 situations. Again, whenever you have a system, you're taking a look at 2 situations or more at the same time. So let's start off by writing an equation for the first one, the one in red. So it says it costs $35. So if I know this is what it cost, this has to be my total. It cost is equal to 1 adult. Okay, so I can say 1, let's see, for adults, let's use X here. So let me just say 1x. And 2 children. Well, children is not the same as adults, so I'm going to use the letter Y. Now, of course, you could use A and C to represent that. So it's 1 adult plus 2 children, so say 2y. Okay, perfect. We have the equation for the first one. Now it says for the other situation here, it costs $60. So I know that this is costing $60 is going to equal to, I have 2 adults in this case. So again, 2x, because x is representing adults, so I say 2x. And then I have 3 children. And remember, children, I was using the variable y, so plus 3y. Now here is my system of equations. This is the 2 situations I'm taking a look at. Now, if I'm smart about this, I don't have to do that much work because it's only worried about the adults. Again, adults is the x. All I'm really caring about in this case is only the x variable. I don't need the y. I could get the y if I wanted to, but I want to do less work here. So let's think about this. How can I get these x's? Okay, I don't want to eliminate them. I want them to stay here because I want to figure out the cost of adult is. I want to try and eliminate these y's, but the issue is I can't multiply 2 by anything to get a -3 and cancel them out. So this is one of those situations where you actually have to multiply both of them, okay, by the least common multiple. So I know that 2 and 3 both go into 6. Why not make the top one, let's make this a -6. Let's make the bottom one a +6. So what do I multiply this by to get a -6? Let's multiply by -3. Everything in here is going to get multiplied by a -3. Now again, of course, -3 times 35. Let me use my handy dandy calculator here. Of course, I'm not going to force you guys to do this. You have a calculator, you can use it too. 35 times 3 is going to give us, well, negative 105 is equal to -3 times 1 is -3x. -3 times 2y is going to give us -6y. Alright. Now, remember, I did this so I get a -6y. I want this to become a +6y. So all I have to multiply is by a +2. Now don't forget, everything has to get multiplied by a 2. So 2 times 60 is going to give us 120 is equal to 2 times 2x is 4x. Now 2 times 3y is going to give us positive 6y. Hey, that's nice because guess what? When I combine these straight down, here I have 120 minus 105, which is going to give me 15, is equal to what is 4x's and negative 3x's. Well, 4x's minus 3x's gives us just simply x. And hey, 6y minus 6y cancels out. Hey, I don't have to do anything else. Hey, I figured out what x is. That's what I was trying to look for. What is the cost of one adult? Well, 1x, one adult here, is going to equal $15. So the cost for one adult is 15 bucks. All right. Now again, you could have eliminated the x's if you wanted to. You just multiply by a negative 2 and you go through. But that would have given you the y variable, and then you have to plug back in to get your x. Now again, I didn't have to get the y because I'm only worried about the cost of an adult. This is what I worried about. So again, work smarter, not harder. Make sure you understand what the question is asking here. All right. So here we go on to the next one. It says, Cora ran 3 miles last week. So there's the 3 miles that they ran, and is running 7 miles per week. Notice the keyword here, per week, from now on. So again, the 7 miles per week is represented right there, and this is the y is representing the total amount. Okay, so this is representing 7 per week. The x represents week, and then y here is representing the total. Okay, total distance. All right, it says Hannah ran 9 miles. That's where we get this 9 from. And we'll run 4 miles per week. So here we have again 4x, and again 4 miles per week. So the x here is representing the number of weeks. Okay, from now on, and of course y is representing the same thing here. The system of linear equations, so they actually did it for us, can be used to represent the situation. Explain what x and y represent in the equations. Well, actually, we did it as we were going. Again, notice 4 miles per week. So again, it's 4x. X is representing weeks. Same thing with the x up above. Y is representing your total distance. They're talking about running, so how much are they running in total after so many weeks? Okay, after 1 week, after 2 weeks, I can plug in for my x's here and find out the total distance for Cora and Hannah. After how many weeks will Cora and Hannah have run the same number of miles? Again, if you want to be specific, total distance is in miles here. So after how many weeks? So I'm worried about how long will it take. And then how many miles is that? And to solve by graphing. Here's the issue, guys. I don't want to solve this by graphing. It's difficult to draw a graph on here. So nope, I'm not going to do it that way. I'm going to actually use the secret sauce here, which is to solve by substitution. I could use elimination. Can I multiply anything by 4 to get a negative 7 out of this so they cancel? Not really. But what I could do is I can take y is already solved for. If I take all of this information here and I substitute in for my other y, if I set these equal to each other because I want to know when they will be the same, I end up with the equation 7x plus 3 is equal to 4x plus 9. Hey, this just becomes a multi-step equation. All right, let's go through and solve this. If I say minus 4x, 7x minus 4x is 3x's, plus 3 is equal to 9. If I subtract 3 from both sides, I get 3x is equal to 6. The last thing I have to do here is divide both sides by 3. I know x is equal to 2. All right, and I will talk about what that means in a second. I need to figure out the y. Again, the way you figure out the y is just plug in whichever one you want. Does not matter. I'm going to pick the first one. Why not? Y equals 7x plus 3. Now I know what x is. X is equal to 2. So I know that y is equal to 7. Not times x, but times 2 plus 3. Y is equal to 7 times 2 is 14. 14 plus 3 is 17. Okay, that's great. That's fine. Fine and dandy. But again, I need to write a sentence. What did I just figure out? X was representing, don't forget, weeks. Okay, Y was representing your total distance in miles. So after how many weeks will Cora and Hannah have run the same number of miles? Okay, in how many weeks? X is representing weeks in 2 weeks. Both will have ran 17 represents the distance, 17 miles. Okay, so make sure you guys give me that sentence. What is it actually standing for? That is very, very important. All right, guys, last example here. All right, it says Jace bought 5 bath towels and returned 2 hand towels. His sister Jana bought 3 bath towels and returned 4 hand towels. Jace paid a total of $124 and Jana paid a total of $24. Right now, they don't give us any question here, but of course, the obvious is, hey, how much does a bath towel cost? How much does a hand towel cost? All right. So what I'm going to do is I'm going to break this video up in so I can finish this up, and then part 2. So I'm going to stop right here. Make sure you guys go to part 2, copy it down. All right, and I'll finish up part 2 in a second.